Hey guys, I'd like to welcome you once again. My name is Saria Theophilus Dugben, a Cisco network engineer. So basically what we're going to be doing here is configuring Ospf to enable inter-network routing across the network. As we have at the moment, these all our points are all green, but we don't have lanes talking to each other. So let's test that out and see, to have an understanding of what exactly I'm talking about. So they are going to fail. Basically they should fail because we don't have a routing protocol to route traffic across the network. So basically that's exactly what I will be helping to show you on this awesome lab that we have here. So with Ospf, basically in configuring Ospf is one of the widely used routing protocol used in the real world. So you really want to have an understanding of what that is. So basically with Ospf, in configuring Ospf, you want to in your Ospf statement, you want to include directly connected networks on a particular router. So for instance, all the networks here, they are all VLANs, they are all networks, as you may understand and know, including the serial connections that are directly attached to the router. So all the networks right here, this network, they will all be part of our Ospf statement, and the same goes for this router and this router. Okay, so with not so much time to waste, let's do just that. So I'm gonna scoop this right over here, and we're gonna do just that. So in configuring Ospf is pretty straightforward. I think it's easy, but you can also, it might be a little difficult to you, but with practice it can seem very easy as well. So you want to do router Ospf, and I want to do 1. Okay, so next you want to give the router an ID. There is an elections that go on with a cluster of Cisco routers. So with these 3 routers, basically there may be an election of who's going to be the designated router and who's going to be the backup designated router. If you have an understanding of how the spanning tree protocol works, is similar to what these guys do. But for in this case, the router ID, the loopback address, and the active router interface, the one with the highest number gets to be the designated router. As in the case of STP, the switch with the lowest priority or the lowest MAC address get to be the designated switch. In this case of the router is the highest loopback, highest router ID, or the highest active interface IP address, who's gonna win the election of being the designated router. So for in our case, I'm gonna, since we are on router 1, we want to name our router 1. It's just, let's to name that because it's router 1. Okay, next you want to include so this is basically one of the simplest configuration. There are a lot of parameters with Ospf, but we're just going to do a simplest configuration of the protocol. So you want to do network. You want to add basically all the network across this. So I've taken the time to list all the networks that I have on this router, and as you can see right here, all the networks gateway. So basically all the .1.1.1 will be .0.0.0.0 to make the network address. All right, so do 192.168.10.0 for network. Okay, this is the 10.0 network, which gateway address is 10.1. If you have an understanding of IP addressing, you will certainly have a clue of what I'm talking about, but that should also be easy too. Now next, you want to indicate the worker mask. Now, in calculating the worker mask, is an inverse of the actual subnet mask. So I've taken the time to do this calculation right here for you. So let me bring this in this column. So the calculation of the worker mask goes this way. So we do have, it's a /24 network. So our address is, our subnet mask for /24 network is 255.255.255.255.0. Now the worker mask is 255.255.255.255. That's the calculation. In order to find the actual worker mask for a for subnet mask, this is the calculation right here. Now 255 minus 255, you get 0. 255 minus 255, you get 0. 255 minus 255, you get 0. Now this is /24, so you got 0 right here and you got 255 right here. So this is the basic calculation. So 0 from 255, you get 255. Okay, it's different with /24, /25, /26, and all the way down the line. So basically, what you will be doing for a class C network, you're going to be doing only subtracting the last bit in the subnet mask from 255, and then you get the last number right here. But if you're going to be dealing with a class B or a class A network, that will be a whole different ballgame. You have to go further deep in to have the calculations right. But since these are our class C networks, that is why we are dealing with the first octet. Okay, so 255.255.0 minus 255.255.255.255. In this case, we got 0.00255. Okay, so that's exactly what we're going to do for our worker mask. So do 0.0.0.0.255. Now you want to place them in an area. Since we don't have a cluster of router here, our area is going to be area 0. Normally area 0 is the backbone area for a router cluster. If we have a multiple area Ospf, where you got area 1, area 2, area 3, basically the backbone for our optimal network design, the backbone is always area 0. But since we don't have cluster, we're just going to use area 0 for our area. So you want to do area 0. So that's the first network, and now we want to do the same for the other network, for all the network attached. 192.168 dot 20.0 00.0.0.255 area 0. Okay, so that's 20, 30, 40, 50. We want to do that for all the networks. So you want to do up arrow, we get draft back in, and then we change that to 30 to make this speed up a little bit. Okay, we do enter, we do the same for the 40, draft back in, change that to 4, got 40, and then network, we do up arrow, we do this, go to 40, we change that to 5. Oh boy, okay, now it's getting messy. We're gonna do 5. We want to put a dot in between. Okay, we do enter. Next, you want to include these directly connected networks in order to have a properly configure Ospf configuration. You want to include these networks right here, these directly connected networks. So we want to do the first 10.10.10.0. so you do network 10.10.10.0. okay, you want to do now for, since is a 252 is a /30 network, as you can see here, we got 255, 255, 255, 252. Now if you subtract 252 from 255, 255, you get 3. So basically our wildcard mask is 0, 0, 0, 3 because it is a /30 network. Alright, you have to understand and know that calculation. I think it's pretty straightforward. So you want to do 0.0.0.3. you want to place that in the same area as the other router, area 0. Okay, so we got 10.10.10.0.0.0.3. you do enter. You want to do the same for this link right here. This link, you do the same for that network. So you do network 10.10.10.10. This network right here is .8. Okay, so you do 8. 0.0.0.3 is also a /30 network, area 0. you do enter. Next, you could do, you don't want routing updates coming out this interface right here, so you could make this a passive interface. And another way to do that, you want to specify, so this is FO00, so you want to say passive interface FA/0. okay, so you don't want routing updates or routing LSAs coming through this LAN network. That would just be burning your more network resources, so you don't want to do that. So passive interface for this interface right here. Okay, so that should be totally fine for this network right here. So you want to do and we should be fine for this router. Next, you want to do the same for this router. So you want to do basically all the connecting router within the network. They are all going to be configured with Ospf. So you do router Ospf 1. Okay, you do router ID. Since this is router 2, do 2. Okay, now you want to do networks. You want to include all these networks in the router Ospf statement. So we do network, you could do net, that should also work. So you want to do 192.168.2.0. so these are all gateways 2.1.4.1.8.1. the network is 2.0, 4.0, 8.0. so you want to do 0.0.0.0.255. it's a /24 network. Okay, 0.0.0.255. you're going to place it in area 0 as well. So we're going to do area 0. you do enter. you do the same for the other network 192.168.4.0, 0.0.0.0.255, area 0. Okay, and the last VLAN network is 192.168.8.0, 0.0.0.255, area 0. Next, you want to do the same for directly connected network. So the 10.10.0 network is also connected to router 2, so as the 10.10.10.4 network also connected to router 2. So you want to include this network right here and this network on router 2 because they are all touching router 2. So you want to do network 10.10.10.0 0.0.0.3 area 0. Okay, I'm going to do net 10.10.10.10.4. 4 is the network. Alright, 0.0.0.3. You want to do area 0. Now you want to make this interface to a passive interface because you don't need routing updates coming through to the LAN network. So you do passive interface FA0/0. Okay, that should be fine. Now they just established a neighbor relationship. As you can see, Ospf adjacency process 1, neighbor router 1.1.1. so this is 1.1.1. Next, you want to come on this interface and do the same. So for this interface, we just have the 99 network, which is our management VLAN. So we want to do router Ospf 1, enter, router ID 3.3.3.3 because this is router 3. You enter. You want to do network 192.168.99.0. Now you want to include this network and this network and this network. All right, this network, you want to also include this network, which is our ISP network on our border router. So you want to do 0.0.0.0.255. okay, 0.0.0.255 area 0. You want to do enter. You do network 10.10.10.4 0.0.0.0.3 area 0. okay, you do network 10.10.10.8. don't forget that. Okay, it's 8. 10.10.n 0.0.0.3 area 0. Now we could also, this is a point-to-point link, so you want to also include this network in our routing statement. So let's do network 10.10.255. okay, 255.252. 252 is the network. 0.0.0.3. That might be in your different area. So we wouldn't include that in our OSPF statement. Instead, we use an IP route out that interface. That should be totally fine too. So now you want to do passive interface for this interface right here. So you do passive interface FA0/0 because you don't want routing out there going on to the LAN. So you do enter. We should be fine. Now to show that routing is going on across the network, let's try that. Now we'll have this LAN talking to this LAN. Normally the first one usually fail, but we should have this LAN talking to this LAN. Okay, for some reason it's sort of slow to converge, but there you go. So they are all talking now, this PC to this PC. That's the first PC for that one, so we're gonna fill this PC to this PC. Now that is successful. Okay, so they are all pinging across the network. They are all talking. Now to sort of enable internet connectivity, we can link our border router with our ISP router. Normally ISP will issue job side of the IP address, and you just configure the interface with that, and then they will do their part of it. But since I am my own network administrator and also my ISP provider, I'm just gonna go ahead with the configuration anyways. So let's do that and see what happens. So we do conft interface sa0/0/0, we do enter, IP add. So as you can see, this is 10.255.255.255. So this is a /30 network. So 253 is this interface, 254 will be this interface. All right, let me just make a note of that so we don't forget it. So the 253 and the 254. Okay, so 253 is right here and 254 is right here. Okay, so let's do just that. IP add 10.255.255.253. okay, 255, 255, 255, 252, 255, 253, 255, 252, by mask. Okay. So we could change our IP address to have a contiguous network. So let's use an address from within this range, but it's also going to be contiguous as well. So let's do 10. Sorry. So we could go by use IP, use the up arrow. Instead of 255, 255, we could use 10.10. Since this is 8, the next one going to be 12. So so 12 is the network. So the 13 will be our next available IP address. So we got 8, 10, 11, and 12. So there you go. So 12 is the network right here. I hope I'm not confusing you now. Okay, so let's do this. 10, 10, 12. There you go. Okay, so this will be 13, and this will be 14. Okay, let's try this out. 255, 255, 255, 252. Okay, now you want to do description. Arrow 3 link to ISP. No short. Okay, now let's enable our ISP and see what's going on right here. Give you a host name, ISP, INTSE0/0/0, enter, IP add 10.10.10.14. okay, remember the 14, 255, 255, 255.252. you enter, description, ISP link to arrow 3 LAN. Okay, and then you do no short. That should turn the interface on. Okay, now basically let's see whether they can route to the internet. They can route to the internet. So what happening, basically you could do IP route right here, and then it will send all traffic to out this interface. So let's do that, and then we'll see what happened. Exit IP route. You want to do quad zeros, 0 0 0 0 0 0 0 0. Okay, and now you want to do the exit interface. Okay, so we do SE 0 slash 0 slash 0 to enter, and we should have all the communication for this network going out that interface. So let's try that out and see. Still filling. Okay, so I think we are missing something, but let's see what we can send to this router right here. That is successful. Okay, I think we are missing this network out of our routing protocol. So basically we wouldn't be able to send communication to the internet. That can also be fixed, but I guess we're gonna do that to another lab. But guys, basically that's how we configure Ospf. To try that, or to check what you've configured, you can do a couple of show commands to see exactly what you have running on your router interface. So let's exit out of here and do show IP route. Show IP route should show us our configuration. So as you can see, this is the code. Basically all the lines you see with 0, they are all Ospf, and all the ones you see with C, they are all directly connected networks. So for this interface, for this router, we have basically 3 networks that is directly connected in our Ospf statement. So that's why we have 3 directly connected network. As you can see, 1 2 3. So we got 10 10 10 4, 10 10 10 8, and 10 10 10 12. So this is directly connected networks, and the others are Ospf information from other networks, okay, from other routers. That's why you have all these Ospfs, because we enable Ospf. As you can see, 192.168.2.0/24. This is the Ospf metric 110, and this is the cost to that network via 10.10.10.5, and this interface that get out to that LAN network. So as you can see, we do have Ospf functioning. Now in order to enable internet, we'll have to add our LAN, this network, basically to our Ospf statement on this router, and then we'll have our LAN network connecting to our ISP. But for now, this is how far I want to stop, and let's hope you have an understanding of how to configure Ospf, and I'll be back here another time with another awesome lab. I'd like to thank you for tuning in. If you can subscribe, that would be great. Leave me your comments and like my page, and just have fun with it. I think it's pretty easy once you put a lot of time and attention to it, and this is just awesome. Once again, my name is Saria Theophilus Stube. I'd like to thank you, and I'll see you around.